Under the stillness of the night, when the sounds of a long day have quietly faded away, the sky above opens into a deep, tranquil expanse, and a gentle feeling begins to drift into the mind. With just a moment of closed eyes, the image of a star-filled sky appears, like a velvet curtain of darkness sprinkled with tiny points of light. Every star is a story. Every shimmer is a message traveling from a distant past. In a moment like this, the world feels wider. We feel smaller, and yet somehow more connected to the vast universe around us. Those quiet lights seem to softly recount billions of years of cosmic history, guiding the listener into a calm, contemplative journey. Within this peaceful space, a simple idea begins to take shape. The universe moves according to timeless principles, laws that appear everywhere, laws that govern every world. People give this idea a familiar but expansive name: universal physics, a common language whispered across planets, stars, storms, and drifting clouds of gas. When we look up at the sky, we're not only seeing stars, we're witnessing the rules that bind all worlds together. This journey begins with the intention of bringing the listener closer to those rules, not through rigid formulas, but through soft, soothing imagery that settles gently into the mind at a restful hour. This is not a lecture. It is a story, a quiet stream of knowledge where every concept becomes as gentle as a passing cloud. Within that stream, the listener will be prepared to drift through the solar system, visiting one world after another, experiencing the extraordinary weather each carries, and eventually hearing the faint whisper of a cosmic destiny, the force that shapes the way everything moves. But before exploring those worlds, one essential question rises. What makes weather possible at all? It sounds simple, almost familiar, yet across the universe the answer becomes far more delicate. Every kind of weather, whether it's a soft rain on Earth, a dust storm on Mars, or a colossal churning vortex on Jupiter, requires two basic ingredients. The first is an atmosphere. Without a layer of gas wrapping around a world, nothing can stir. A planet without an atmosphere is like a silent, empty plain without wind. Everything remains still beneath the unfiltered glare of its star. No air, no clouds, no vapor, nothing to move. Only silence and the raw truth of temperature. The second ingredient is a source of energy, usually the warmth and light from the star it orbits. Energy heats a world's surface, warms its skies, and creates differences in temperature. Those differences are what cause motion: warm air rising, cooler air sinking, pressure shifting, wind forming. Without energy, even the thickest atmosphere would hang motionless, like a curtain frozen in place. When both conditions exist together, weather is born. When they act powerfully, weather becomes complex and wild. When they act gently, weather becomes calm and mild. And when one of them fades away, the world sinks into quiet, nearly absolute stillness. Mercury is the clearest example. Small and scorched, it can barely hold onto an atmosphere at all. The solar wind is so strong that every molecule of gas is swept into space. Without an atmosphere, Mercury cannot create clouds, winds, or storms. Daytime burns like a furnace. Night plunges into deep cold. The contrast is so extreme that materials on its surface expand and contract relentlessly, but still no weather forms. Missing the first condition, the world becomes nothing more than silence, craters, and ancient scars. But just a little farther from the sun, the picture transforms completely. Other planets carry atmospheres that are thicker, broader, and fully alive under the sun's touch. no matter how strong or faint that sunlight may be. And here, universal physics begins to reveal its diversity. Some worlds have skies as dense as an endless ocean of haze, where raindrops of acid form and vanish before touching the ground. Others need only a hint of warmth to stir up dust storms that last for months. Still others have atmospheres made not of air, but of methane, ammonia, or hydrogen, breeding storms so large they could swallow Earth whole. As the journey deepens, the listener encounters tempests so long-lived they seem immortal. Jupiter's enormous storm that has raged for centuries, Saturn's hexagonal cyclone at the North Pole that remains perfectly shaped after decades of observation. Far beyond, on the distant ice giants, winds can race faster than the speed of sound, sweeping across blue landscapes cold and vast as drifting frozen oceans. These worlds do more than show the strength of winds and storms. They tell a shared story. Despite their shapes and extremes, every phenomenon follows universal physics. One set of rules, infinite expressions. Ahead lies a path through all these worlds. Each planet becomes a chapter in the tale of cosmic weather. Some quiet, some fierce, some strange, some breathtaking. And as the journey unfolds, the listener arrives at its final part. The place where cosmic destiny emerges as a greater rhythm, explaining why planets form, why storms rise and fall, why comets appear from darkness, and why everything in the universe seems connected by a silent thread. And all of this begins tonight, beneath a sky full of stars, in a moment when everything slows, and the mind opens to receive a long, gentle story. A story whispered by every world, every storm, every drifting current of air. All it takes is a quiet heart, and the journey through the universe begins in peace, under the starlit sky of the previous chapter, just as the idea of universal cosmic laws begins to settle gently into the mind. The journey shifts, ever so softly, from the vast expanse where every world drifts patiently around the sun. Our first stop emerges like a small, weathered stone wrapped in quiet mystery. If universal physics is the great symphony of the cosmos, then its opening note lies closest to the sun, Mercury. Not because it roars or rages, but because its absolute silence reveals how essential atmosphere and energy truly are in shaping weather. From the gentle calm of Earth's night sky, the story now moves to a world where change is nearly impossible, a world where silence becomes the dominant tone. Mercury, small and solitary, stands so close to the sun that the very space around it seems to tremble with light and heat. And yet, despite receiving such intense radiance, it remains one of the quietest places in the entire solar system. Not the quiet of a light breeze or a soft drizzle, but a silence so absolute that no wind brushes its cliffs, no clouds soften the sun's glare, no storms swirl across its plains. The reason is simple and deeply revealing. Mercury has almost no atmosphere. Without a substantial layer of gas to hold warmth, absorb light, or move with shifting temperatures, the planet becomes like a giant slab of rock placed too near the universe's furnace. The lightest molecules of gas were swept away by the solar wind billions of years ago, leaving behind only a whisper-thin exosphere, far too thin to create weather in any sense we know. And so Mercury stands as the clearest example of a world where, in the absence of atmosphere, weather doesn't merely weaken, it ceases to exist entirely. In that absence, only extremes remain. When its sunlit side faces the sun, Mercury's surface bakes at over 400 degrees Celsius, hot enough to deform ordinary solid materials. But as the world slowly rotates and its night side drifts into shadow, the temperature plunges to nearly 170 degrees Celsius, a difference of more than 1,000 degrees, something unimaginable on Earth. Yet on Mercury, it repeats endlessly without pause. A single day on Mercury lasts for months in Earth time. Dawn and dusk stretch on for weeks, as though time is being pulled thin. Imagine the sun rising on Mercury, a blazing sphere slowly lifting above a jagged horizon, its light so intense it could turn the surface into a blinding mirror. Yet the sky remains pitch black, because there is no air to scatter the light, no clouds to tint the sunrise pink, no morning mist to hint at change, no gentle warmth carried by a breeze. Only fierce light and deep darkness side by side, bound together like opposite halves of a single, merciless coin. As sunlight spreads across the ground, nothing stirs. No winds to move the heat, no currents to shift the air. The surface simply absorbs, accumulates, and radiates heat in total silence. Craters of every size cover the land, evidence of countless meteorites that have struck Mercury over billions of years. Its air is far too thin to slow or burn incoming rocks, so the planet endures every impact. Each crater remains perfectly preserved, untouched by rain, wind, or erosion, because nothing exists to reshape it. At night, when the sun disappears beyond the horizon, the ground cools with startling speed, turning brittle with cold. The already thin exosphere becomes effectively meaningless, unable to trap any warmth. For months of darkness, Mercury sinks into absolute stillness. No wind, no shifting dust, no motion other than the silent expansion and contraction of its surface. To stand there would be to see nothing but darkness and feel a cold that pierces through physical matter itself. A world with only two states, searing heat and deadly cold, daylight and darkness, without transitions or gentle rhythms. And within that stillness, Mercury offers a profound lesson about universal physics. Weather is not guaranteed. It relies on delicate conditions, a sufficiently thick atmosphere to store and carry heat, an energy source balanced enough to create contrast without destroying, and a planet massive enough to hold its gases close. When these elements are absent, a world becomes a place of extremes and silence, bare and unchanging. Mercury is the perfect opening chapter for understanding cosmic weather, because from its stillness, we clearly see the value of both atmosphere and energy. As we leave Mercury and drift toward the next worlds, the contrast grows sharper. From a place without clouds, winds, or storms, the journey soon leads to Venus, a world where the atmosphere is so thick that sunlight struggles to break through, where acid rain forms and evaporates before touching the ground, where everything is wrapped in a suffocating shroud of toxic haze. From the absolute silence of Mercury, the story flows into the oppressive intensity of Venus, a world where storms are not born from wind alone, but from pressure, heat, and the swirling mysteries hidden within its dense yellow clouds. And so this sleepy journey continues, unfolding the solar system's secrets one layer at a time. From extremes of stillness to extremes of chaos, all quietly shaped by universal physics. When leaving Mercury, where everything is wrapped in the absolute stillness of a world without air, the journey opens again with a soft, almost seamless shift. From a planet without clouds, without wind, without storms, we move toward a world that is the complete opposite. A place cloaked in an atmosphere so thick that sunlight barely slips through. A place where even the slightest motion in the air becomes a slow-burning storm that never fully ends. If Mercury is the symbol of weather's silence, then Venus is the embodiment of its overpowering presence. Two neighboring worlds in orbit, yet so drastically different they might as well belong to separate universes. And it is this stark contrast that makes the transition feel so natural, like the answer to the question, what happens when an atmosphere doesn't disappear, but becomes too thick? Now the journey drifts gently toward Venus, the twin sister of Earth, carrying a fate entirely its own. Venus is often called Earth's twin because of its similar size, mass, and density. From a distance, it would be easy to believe the two must share the same nature. But up close, the difference is astonishing. Where Earth offers oceans, clouds, and breathable air, Venus is enveloped in a dense yellow haze, so heavy that sunlight filters through like a slow, narrowing blade. The planet feels like a sealed room where heat is trapped endlessly, unable to escape. The result is a greenhouse effect, pushed beyond anything we can imagine. Surface temperatures on Venus reach about 460 degrees Celsius, hotter than Mercury's sunlit side, even though Venus is farther from the Sun. This happens because its carbon dioxide-rich atmosphere traps heat like an immense blanket. That blanket is so thick that the pressure on the surface is nearly 100 times stronger than on Earth. Standing there would feel like being crushed beneath the weight of a deep ocean. The world is not just hot. It is dense, heavy, and entirely enclosed. The sky of Venus is filled with sulfuric acid clouds, forming a permanent yellow shroud. Sunlight must thread its way through miles of toxic vapors before touching the ground. Within those clouds, droplets of acid condense into rain, but they never reach the surface. The heat is so intense that the rain evaporates midway down. They are raindrops that never complete their journey, born in the clouds but lost before they ever meet the ground. Imagine that scene. Above, sulfuric clouds swirl softly, forming a thick curtain that hides any hint of blue sky. Below, the ground glows with heat hotter than Earth's metal-melting furnaces. Together, they create a suffocating realm where every movement happens slowly, but with immense force. Everything on Venus seems to simmer, like a giant pressure cooker constantly swollen with heat and weight, with no release. High above the surface, winds can reach over 300 miles per hour, about 480 kilometers per hour. They sweep the sulfuric clouds into enormous, swirling belts that circle the planet endlessly. Strangely, while the upper atmosphere races wildly, the ground below sits in near stillness. Winds on the surface blow at only about 4 miles per hour, slower than a walking pace. But don't be fooled. Under a pressure 90 to 100 times that of Earth, even a gentle breeze carries the force of a storm, strong enough to push or break nearly anything it touches. One of Venus's most captivating mysteries lies near its poles, especially the South Pole. There, a double-eyed cyclone spins, two storm centers rotating around each other in a structure thousands of miles wide. It is a rare cosmic formation, almost artistic in shape, yet born from harsh and relentless conditions. Seen from afar, it resembles two glowing whirlpools turning quietly within the dense yellow haze, like windows into a world shaped by pressure, heat, and turbulent motion. Occasionally, lightning flashes within the sulfuric clouds, not the branching, visible lightning we see on Earth, but sudden, muted bursts of light that appear and vanish behind thick mist. These sparks may last only fractions of a second, but they reveal the hidden chaos pulsing beneath the planet's deceptively calm veil. They remind us that beneath the soft yellow glow lies a world governed by fierce forces in constant motion. Venus does not have sunrise in the usual sense. The sun does not rise over a blue sky. nor set in orange and pink. Everything is drowned in one endless shade of murky gold, where light is scattered so thoroughly that time loses its familiar markers. There is no true day or night as we know them, only varying degrees of dim yellow light depending on where the planet is in its slow rotation. And yet, within this suffocating landscape, Venus holds a strange kind of beauty. There is beauty in its towering cloud layers that spread like a golden ocean across the sky. Beauty in the acid rain that never touches the ground but leaves ghostly streaks suspended in the air. Beauty in the twin-eyed cyclone turning like an ancient emblem. And beauty in the silent flashes of lightning, like secret messages sent into space. In this sleepy journey, Venus appears as a gentle yet profound story. A world soft in color but powerful in nature, beautiful in a dangerous way. A lesson in how an atmosphere can transform a planet into paradise, or into something far more hostile. From Mercury's silence to Venus's suffocation, the journey continues with steady rhythm, guiding us next toward Earth, the only world with blue skies, fresh rain, gentle winds, and a delicate balance of everything needed for life. In the following chapter, the story returns to something familiar, so we can better appreciate the uniqueness of the planet we call home. Leaving Venus, where thick yellow clouds seal away every breath of light. The journey feels as if it is slipping out of a sweltering, heavy chamber and returning to a world we know by heart. After passing through two extremes of atmospheric existence, Mercury with almost no air at all, and Venus with far too much, the next step brings us to a delicate middle ground between those opposites. That world is Earth. In the gentle rhythm of our journey, Earth appears like a soft inhale, a quiet pause before we wander on to the colossal storms of more distant planets. Not because Earth is simple, but because here the complexity of an atmosphere becomes a familiar kind of beauty. And it's this closeness, this lived intimacy, that makes this chapter feel like a comforting anchor in the story's flow. Earth, the only known blue world carrying life, rises like a symphony in balance. Sunlight, rain, wind, and ocean all moving in harmony. Its atmosphere is thick enough to protect, yet light enough for clouds to drift, winds to blow, and rain to fall. Not too thin like Mercury's, where silence reigns, and not too thick like Venus's suffocating shroud. In this graceful equilibrium, Earth's weather follows a soft rhythm that allows life to emerge, grow, and evolve. Picture a quiet morning by the sea, where a gentle breeze drifts in from the ocean, carrying a faint hint of salt. The wind isn't strong or weak, it's just enough to ripple the water and make the sky seem a little wider. Earth's air, a blend of nitrogen and oxygen, creates a light, breathable envelope around the planet. When sunlight touches the surface, water evaporates, clouds form, and rain falls again to nourish the land. It is an exquisite cycle, and through the lens of science, it is universal physics expressed in its most tender form. On rooftops, rain can fall in soft, steady rhythms. When clouds gather thickly, each drop rolls down, sinking into soil, into rivers, into the sea. These are sounds humans have known since birth, sounds that relax the mind and ease it towards sleep. Earth's rain is not acidic like Venus's. It doesn't evaporate halfway down, nor melt in scorching layers of air. It reaches the ground, cooling the world and leaving behind that unmistakable smell of damp earth, something only Earth can offer. In summer, a passing thunderstorm announces itself with distant rumbles and soft flashes of light, signs of shifting layers of air above. All of it forms an invisible map of energy. And yet, no matter how fierce the storm, sunlight eventually returns, and the air quiets again. Unlike worlds where storms last centuries or months, Earth's storms have a beginning, a peak, and an end. A tropical cyclone may roar across the ocean, shaking everything in its path. But it, too, dissolves and gives way to calmer days. When the storm fades, Earth's sunsets can be breathtaking. The sun sinks low, its light scattering through lingering droplets to form a rainbow, an arch of 7 colors stretching across the sky. No other planet in the solar system can create something so simple and yet so gently beautiful. Venus's clouds are too thick for colors. Mars's air is too thin for rainbows to appear. Only Earth possesses the perfect combination of air, moisture, and sunlight to paint the sky this way. This unique atmosphere also shields Earth from harsh radiation and helps maintain stable temperatures. Because of this, Earth's weather holds a balance few worlds can match. Warm days, cool nights, rain, sunshine, most of it within the bounds that life can endure. Even the planet's more violent phenomena, hurricanes, tornadoes, tsunamis, are things we can study, predict, and prepare for. With science, these events become part of a known cycle rather than an unknowable fear. Earth also carries a collection of gentle weather moments that few other worlds could ever replicate. A misty autumn morning, a spring afternoon filled with birdsong, a winter night when snow falls quietly on rooftops. These moments form memories and emotions understood by nearly everyone, without explanation. When speaking of Earth's weather, the story feels personal because each listener has experienced it firsthand. In many ways, Earth is a gift tuned with extraordinary precision. Its distance from the sun allows water to exist as solid, liquid, and vapor. Its atmosphere holds enough warmth to keep nights from freezing like Mercury's, yet still releases enough heat to avoid Venus's pressure cooker fate. Its layered structure, from the troposphere to the stratosphere, creates a stage where water vapor, clouds, and sunlight constantly paint new scenes. And in this peaceful pause within our solar system journey, Earth feels like a gentle reminder that life survives thanks to conditions that are fragile, miraculous, and rare. Soft breezes, warm rains, colorful sunsets, each one the product of a balance found nowhere else. As this chapter settles, the story begins to open forward once more. From this tender home, we drift away from familiar skies and toward harsher realms, toward the red dust of Mars, where storms can swallow continents, and universal physics takes on a rugged, desolate form. In this lull of the journey, the listener prepares to step into a world of wind, dust, and muted red storms, where Mars waits ahead, leaving Earth with its gentle air and soothing rains. The journey carries us farther outward, away from the familiar balance of our blue home, and into a world painted in an entirely different tone. If Earth is the soft resting point of the voyage, then Mars opens a brand new chapter. A landscape no longer tender, but dry, empty, and steeped in the quiet of a planet that has lived through too many changes. From a clear blue sky, we step into a pale red one, where faint sunlight falls across stretches of dust and stone. The transition isn't abrupt. It feels like a long sigh, guiding the listener from the softness of home into the thin, trembling stillness of a distant world, one that once held rivers and flowing water, but now keeps only silent traces hidden beneath layers of red dust. On Mars, everything carries a cold, lonely beauty. The planet is smaller than Earth, and its atmosphere is only about 1% as thick as the air we breathe, leaving the ground nearly exposed to the deep freeze of space. Daytime warmth is modest at best, and nighttime temperatures often drop to 80 degrees or lower. In this thin air, sound struggles to travel, heat slips away easily, and the wind cannot offer warmth. Yet within these limitations, Mars produces some of the most distinct weather found anywhere in the solar system. Most famously, its dust storms. Across its vast plains, landscapes stretched out like pages abandoned by time. Small but captivating columns of swirling dust often appear. These are dust devils, slender spirals born when sunlight warms a patch of ground just enough to make the air above it rise and twist. Because the atmosphere is so thin, Martian dust devils lack the violence of Earth's tornadoes, yet they can grow astonishingly tall. Some reach nearly 800 meters, lifting fine iron oxide dust into soft orange-red spirals that look like faint ribbons of fire drifting toward the sky. Under the dim Martian light, they spin quietly, as if performing a slow dance in the planet's deep silence. Sometimes these dust devils do an unexpected kindness for rovers. When dust piles onto their solar panels, blocking precious sunlight, a passing dust devil can sweep them clean, giving the robots more days, weeks, or even months of life. But that same dust is also what fuels Mars's most formidable phenomenon, storms that can engulf the entire planet. Every few years, during the southern hemisphere's summer, extra sunlight warms the surface unevenly. Hotter air rises, and small storms begin to form. When several of these systems merge, they can grow into a colossal dust event spanning millions of square kilometers. Slowly, fine particles lift everywhere, spreading outward until the entire sky is swallowed. Sunlight dims. The world sinks into a state resembling an endless sunset, lasting not minutes, but weeks or even months. In such storms, the sky thickens into a deep orange haze, as if a giant curtain has been drawn over the planet. The iron oxide, dust is so fine, just a fraction of a grain of sand, that it becomes easily charged and remains afloat for long stretches. With no rain to wash it away, the Martian atmosphere grows more opaque each day. Less sunlight reaches the surface, and the already cold air grows colder still. These storms are not violent in the earthly sense. No roaring winds, no towering waves, but they are troubling in their persistence and scale. For rovers like Opportunity and Spirit, a global dust storm is a harsh test. When sunlight can't penetrate the dusty sky, their solar panels go dark. The rovers fall into sleep mode, hoping for the storm to pass. Some awaken when the light returns. Others never do. Their final moments become quiet stories scattered across an endless red desert. Mars also experiences seasons, thanks to a 23-degree axial tilt much like Earth's. This tilt shapes annual cycles of wind across the hemispheres. Spring and summer bring more dust devils. Winter settles into a deeper stillness. Global storms almost always arise only when sunlight reaches its strongest, when enough energy is available to lift billions of dust grains into the sky. When a storm finally weakens, the planet slowly reveals itself again. A faint hint of blue may appear near the horizon, a thin, washed-out color created as light scatters through Mars's CO2 atmosphere. On a calm Martian evening, the sun appears far smaller than on Earth, just a pale dot hanging in an orange sky. The sight makes Mars feel old and tired, as though it is exhaling after billions of years of erosion, freezing, and quiet erosion. And yet, in this desolation, there is beauty. Mars is like an ancient diary covered in dust. Beneath that dust once flowed rivers and lakes. Its deep canyons and wide plains speak of a time when its weather was far more alive than it is today. Now, only dust storms interrupt the long silence, like rare memories of a world that once brimmed with motion. Mars evokes a gentle kind of sympathy, as though we're standing before a world that cannot fully revive itself, yet still tries to send small signals. Slender dust devils, muted red storms, a faint glow of sunlight falling from far away. All of it a reminder that weather, no matter how fragile, continues to tell the story of its world. And as this chapter closes, the journey prepares to move on, to a place entirely different, where storms don't just lift dust or dim the sky, but could swallow Earth whole if placed beside them. From the silent red desert, the story now drifts toward the swirling clouds of the giant Jupiter, where weather is no longer a gentle breath, but an eternal storm. Leaving Mars, with its muted red tempests and the delicate whirl of dust devils rising from its cold ground, the journey feels as though it is being lifted from a fragile desert into the domain of forces far greater. After passing through dryness, thin air, and the faint, weakened breaths of a world that once held water, the story opens into the deeper expanses of the solar system. From a place where the sky can barely lift a handful of dust into swirling spirals, we now step toward a world where winds are no longer gentle currents, but powerful rivers of motion flowing through towering cloud layers. If Mars is a quiet world interrupted by storms, Jupiter is a world where storms are the nature of the planet, where turbulence is not an exception, but the rule. The transition feels like leaving a small room with a drifting breeze and entering an immense hall where energy coils endlessly. Here, storms do not have beginnings or endings. They exist as eternal whirlpools, like fingerprints carved into a planet made of wind and cloud. Jupiter, the largest gas giant in the solar system, has no solid surface to stand on, no ground to place a marker. Everything beneath its cloud tops is layers of gas growing denser, more compressed, hotter with depth. In this massive sphere, weather doesn't rule a region or a hemisphere. It rules the entire planet, from pole to pole. The striped bands encircling Jupiter are living evidence of its powerful atmospheric flows, shaped by the fastest rotation of any planet in the solar system. From afar, Jupiter resembles a colossal painting, bands of white, gold, brown, and orange blending and weaving across its surface. These patterns are never still. They shift, drift, and stretch like ribbons carried along a river. And among all these flowing colors, one feature has captured human eyes for centuries: the Great Red Spot. The Great Red Spot is an enormous anticyclonic storm, so vast that Earth could fit inside it with room to spare. Based on observations dating back to the 1600s, this storm has persisted for over 300 years, perhaps much longer. Its length once spanned more than 3 times Earth's diameter, but over time, it has slowly shrunk. The contraction is gradual yet steady, as though this colossal storm, one that has outlived entire eras of human history, is quietly aging. At the edges of the Great Red Spot, winds can exceed 300 miles per hour. If such winds produced sound that we could hear, they would roar with unending ferocity. Yet on Jupiter, without a solid surface or an atmosphere like Earth's to carry sound, these terrifying forces unfold in near total silence. Inside the planet's vast clouds, lightning flashes with a power many times stronger than Earth's. They appear as brief explosions of light inside dark cloud layers, bright one moment, gone the next, leaving only the contrast between immense energy and the quiet void around it. But Jupiter doesn't host just one legendary storm. Our atmosphere is full of them, bright white spots marking convective systems, brown ovals as low-pressure regions, all swirling, merging, and breaking apart in ever-shifting cycles. Ammonia, water vapor, and hydrogen sulfide form intricate patterns in the thick cloud layers, painting scenes that transform minute by minute, like a mural that repaints itself constantly. Jupiter's storms are not powered primarily by sunlight. Instead, the planet generates its own heat from within, energy released by slow gravitational contraction. Deep below the swirling atmosphere lies a core of intense warmth that fuels powerful convection, energizing storms and allowing them to persist for centuries. Because of this, Jupiter's weather does not rely on day or night, nor on solar heating. Its storms live off the planet's internal fire. Violent convection produces high-speed jet streams racing around the planet. These jets crash into each other, twisting clouds into their iconic patterns, making Jupiter look like a living giant that breathes deeply, slowly, but with monumental force. The ceaseless motion gives the sense that Jupiter is a vast organism, its skin a swirling tapestry of colors responding to every pulse of internal heat. Within this endless choreography lies a unique emotion: endurance. A storm on Earth lasts days, a storm on Mars, months. But on Jupiter, storms can last through centuries, surviving long past the people who first observed them, persisting from the era of Newton's telescopes to the age of spacecraft like Juno, which now sends back breathtaking images of every curling cloud line. To observe Jupiter from afar is to witness a painting that never finishes, one that changes constantly, yet never loses its character: vastness, motion, power. Here, weather reaches an extreme, the scale magnified tenfold, 100-fold, beyond anything familiar to us. As this chapter settles into quiet, the portrait of the gas giant stands clear, etched by eternal storms and swirling bands. But the journey continues. Beside Jupiter lies another magnificent world, its pale golden hue embraced by brilliant rings. From Jupiter's endless red storm, the story drifts on toward Saturn, a place of elegant cloud bands and a mysterious geometric wonder at its north pole, opening a new chapter of beauty and intrigue. Leaving Jupiter, its endless vortices and the ancient great red spot watching like an old eye amid rolling clouds, the journey drifts gently toward a world where energy is still fierce, yet wears a softer, more graceful face. If Jupiter is a symphony of turbulent colors, a giant's breath etched into storms that never rest, then the next world brings a different emotion: elegance, quiet rhythm, and a touch of celestial poetry. From Jupiter's swirling marbled canvas, we slide toward the serene silhouette of Saturn, a planet known not only for its unusual weather, but for the unmistakable beauty of the luminous rings circling its pale golden form. The transition feels like moving from a powerful crescendo into a tender lullaby, from relentless spirals into smooth, measured rotation. Saturn appears like a vast gemstone, wrapped in icy, shimmering rings that stretch for hundreds of thousands of kilometers. These rings are made of billions of icy fragments, from tiny grains to chunks meters wide, all orbiting in a strikingly precise harmony, as though an unseen hand has balanced every particle into place. From afar, the rings drift like calm ripples across a still lake, creating one of the most breathtaking images humanity has ever witnessed in the solar system. But Saturn's beauty lies not only in its rings. Beneath that soft halo of light, a mysterious story of weather unfolds, one that makes this planet among the most intriguing of all. The most famous of these mysteries is the Hexagon at the North Pole, a geometric storm unlike anything else in nature. This hexagon spans tens of thousands of kilometers, its 6 edges so sharply defined that it seems impossible they were sculpted by wind and gas alone. Each side stretches longer than Earth's diameter, yet the shape has remained stable for decades of observation. At the center of this hexagonal frame lies a swirling polar cyclone, its eye nearly 50 times the size of Earth's typical hurricane, a masterpiece of atmospheric dynamics found nowhere else in the solar system. The hexagon is not a typical cyclone or anticyclone. It is thought to be a giant standing wave, a powerful jet stream circling the pole at nearly 300 mil/, about 500 kilometers h. As this jet wraps around the pole, it bends into sharp angles, forming a perfect 6-sided shape, like an ancient symbol engraved on the top of the planet. Despite the fierce winds, the overall structure remains remarkably steady, as if someone etched a timeless pattern into Saturn's sky. Imagine hovering above the icy rings, watching their shadows sweep gently across the golden cloud tops. Half the planet glows in sunlight, the other half rests in darkness. Saturn looks like a world poised between 2 realms, gentle in appearance, immense in reality. Where light falls, the cloud layers reveal their movement more clearly. Hydrogen and helium flowing at over 1,000 miles per hour, shaping smooth yet forceful bands around the planet. And the hexagon is not the only wonder. Every few years, or sometimes only once in decades, Saturn erupts with a legendary event known as the Great White Storm. These storms begin as small, bright clouds that quickly expand, becoming enormous plumes wrapping around the entire globe. They last for months, leaving long-lived scars in the atmosphere. Even lightning behaves differently here. The Cassini spacecraft once recorded lightning bolts on Saturn up to 10,000 times more powerful than those on Earth, brief flashes that light up the yellow clouds without a sound. With no solid ground and no Earth-like medium to carry noise, each lightning strike glows alone in the silence, creating a scene that feels both majestic and distant. Seen from far away, all these elements blend into a magnificent tableau. Powerful jet streams flowing like endless rivers of gas, silent lightning flickering within pale clouds, delicate rings gliding around the planet like thin bands of silk, and at the North Pole, the slow, deliberate rotation of a perfect hexagon, a rhythm only the universe could compose. Saturn's beauty stands in contrast to Jupiter's. If Jupiter embodies raw energy and wild motion, Saturn represents structure, grace, and delicately balanced force. Its rings are like a visual lullaby, while its hexagonal storm is a quiet demonstration of universal physics at its most refined. Everything on Saturn is both strong and gentle, delivering a sense of peace within a vast and dynamic atmosphere. As this chapter settles, the listener is placed in a quiet cosmic hall where icy rings drift through distant sunlight. But the journey is far from over. Beyond Saturn lie colder, darker regions, where an ice giant tilts at a strange angle and supersonic winds sweep across pale blue clouds. From the softness of Saturn's rings, the story now prepares to glide into Uranus, a world of silent cold and hidden motion waiting to be revealed. Leaving Saturn, with its shimmering rings and the slow-turning hexagon carved like an ancient symbol into its North Pole, the journey drifts farther outward, into regions where sunlight becomes little more than a pale dot suspended in cold darkness. From the soft, symmetrical glow of Saturn's luminous bands, the story leads us to a world that feels entirely different, quieter, more withdrawn, almost sealed within its own stillness. If Saturn is a graceful melody, then the next world is a long, sustained low note resonating gently in the dark. From Saturn's warm golden hue, we step into the cool, subdued blue of Uranus, a planet where silence is woven into its very nature. Uranus is one of the solar system's two ice giants, so distant that sunlight takes nearly 3 hours to reach it. Seen from afar, it appears as a perfectly smooth sphere, a soft blue orb painted with a single brushstroke. Unlike Jupiter's turbulent swirls or Saturn's delicate atmospheric bands, Uranus shows almost no patterns at a glance. Its surface seems still, calm like a frozen lake that has not felt a ripple in ages. Yet perhaps the most unusual feature of Uranus is not its color, but its orientation. Unlike other planets spinning upright like tops, Uranus lies almost entirely on its side, with a tilt of more than 97 degrees. It rolls around the sun like a giant marble tipped over. This extreme tilt creates seasons unlike anything else, each lasting 21 Earth years. Imagine half the planet plunged in darkness for decades, only to switch suddenly to decades of unbroken daylight. This strange rhythm shapes every whisper of weather Uranus can produce. For many years, scientists believed Uranus was almost meteorologically dormant. When Voyager 2 flew past in 1986, the spacecraft saw only a smooth blue atmosphere. No dramatic storms, no swirling bands, nothing to hint at inner motion. Uranus seemed like a quiet giant, almost asleep, but that stillness was only a long slumber. As Uranus approached its spring, when sunlight finally began sweeping across its equator for the first time in decades, subtle changes emerged. From Earth, telescopes like Hubble detected faint white spots drifting across the planet's pale surface. These were small methane clouds, brighter than the surrounding atmosphere. Alongside them came weak but genuine storms, delicate strokes of motion across the otherwise featureless blue. They were not fierce like Jupiter's tempests or Saturn's hexagonal cyclone, but they proved that Uranus was not truly silent. Its rhythm was simply slower, deeper, and more reserved. Winds on Uranus can reach hundreds of meters per second, swift, icy currents sweeping across thin methane clouds in an environment so cold it nearly touches the natural lower limit of temperature, around 220 degrees Celsius. At such extreme cold, almost everything freezes, and atmospheric motion unfolds with a dreamlike softness. To an observer floating nearby, the rare clouds would appear as faint white smudges drifting above the turquoise-blue globe, gathering in gentle storms, then dissolving as though they had never existed. Uranus also carries a ring system of its own, dim, narrow, and much harder to see than Saturn's, but present as thin, dark bands circling the planet. These rings add to its mysterious character, like a shadowy scarf wound around its quiet blue form. The planet's tilted rotation gives rise to another strange phenomenon. Its poles, in turn, aim directly at the sun for decades at a time. When this happens, one hemisphere is drenched in uninterrupted daylight, while the other is locked in a long, frozen night. These extreme seasons may be responsible for the occasional bursts of atmospheric activity observed near equinox. And yet, for most of its long orbit, Uranus remains peaceful. It behaves like a solitary performer who rarely steps onto the stage, yet when it does, the effect is unmistakable. Each storm that appears and fades on its pale surface, each drifting methane cloud, feels like a quiet exhalation from a world that moves at a slower cosmic pace. In the distant dark, Uranus feels like a contemplative giant turning softly under a faint blue glow. Not loud, not violent, not radiant, but beautiful, quietly, ethereally beautiful. There is something meditative here, something melancholic, something serene, as though Uranus is holding an old story that only the cosmos itself remembers. And as this chapter gently closes, the journey prepares to travel even farther, leaving behind Uranus's tranquil blue silence and heading toward a world where winds reach unimaginable speeds. From pale, subdued quiet, the story flows toward the deep cobalt of Neptune, where the fastest gales in the solar system sweep across a vast ocean of clouds, opening the next movement of the cosmic weather symphony. Leaving Uranus, with its quiet blue glow and its sideways rotation drifting like a slow breath of the cosmos, the journey moves even farther outward, toward a realm where sunlight fades into a thin, ghostly trace. Out here, the sun becomes only a dim spark clinging to the edge of an endless horizon. From the meditative stillness of Uranus, we enter a domain where that calm suddenly gives way to something far more turbulent. Yet everything unfolds in the perfect silence of space. If Uranus is a contemplative giant that speaks only in soft, occasional whispers of storms, the next world is where wind itself becomes a force beyond anything humans have ever imagined. A world whose gales surpass every known limit. This is Neptune, the deep blue tempest at the outer rim of the solar system. Neptune appears like a dark sapphire turning in the void. Its color is more than beauty. It speaks of chemistry, methane absorbing red light and reflecting back a rich, mysterious blue, like an ocean without a shore. But the calm, glass-like appearance is deceptive. Beneath those layers of smooth color lies a world in constant upheaval. When Voyager 2 flew past in 1989, the first human eye to truly see it, scientists discovered immense dark storms swirling across Neptune's surface, some large enough to swallow Earth. The most famous, the Great Dark Spot, loomed like a massive shadow gouged into the planet's atmosphere. But unlike Jupiter's Great Red Spot, Neptune's storms are fleeting. A few years after its discovery, the Great Dark Spot vanished entirely, replaced later by new storms forming elsewhere, as though the planet were drawing and erasing its own features in an endless, restless cycle. Neptune's winds are the fastest in the solar system. They blow at more than 2,000 kilometers per hour, supersonic speeds unmatched by any other world. These winds whip through the frigid methane atmosphere, tearing high-altitude clouds into long, delicate streaks of pale white against the planet's deep blue. Seen from afar, these clouds skim across Neptune so quickly they seem to appear and fade in the same moment, giving the impression of a world always mid-motion, never pausing, never truly still. Thin clusters of frozen methane form faint white patches, small signatures of active weather systems shaped by extreme cold and enormous pressure. Temperatures plunge near 220 degrees, making the air brittle, the clouds sharp-edged, and the atmosphere easily sculpted by howling winds, as if everything were made of icy smoke. Remarkably, even at such a staggering distance, where sunlight has weakened to just 1/900 of what reaches Earth, Neptune still generates violent storms. This reveals something crucial. Its weather is not powered by sunlight, but by internal heat. Neptune gives off far more energy than it receives, driven by a mysterious warmth rising from deep inside. This internal engine fuels its supersonic winds, like a cold, blue heart beating fiercely at the edge of the solar system. The dark storms of Neptune behave almost like temporary shadows, rapid, frigid whirlpools that appear, migrate, and dissolve unpredictably. Hubble has watched them shift in size and drift across hemispheres, showing that Neptune's atmosphere is astonishingly dynamic. A single storm can last years, then vanish without leaving a trace. One can imagine the scene from a distance. Thin white clouds racing across cobalt blue skies, whipped into invisible spirals by winds moving faster than sound. Yet for all that violence, everything plays out in utter silence, because space carries no sound. This contradiction makes Neptune hauntingly beautiful, a world roaring with energy and physics, yet quiet as a frozen dream to the senses. And Neptune holds more mysteries. Beneath its cloud layers may lie oceans of water, ammonia, and methane in exotic states, liquid, icy, or something in between, pressed under impossible pressures. Deeper still, methane molecules could break apart, releasing carbon that falls as diamond rain. If this truly occurs, then Neptune may be a world where shimmering crystals tumble downward like dark, glittering snow, a breathtaking image that adds yet another layer of wonder to this distant planet. From Uranus's pale stillness to Neptune's swirling ferocity, our journey feels like moving from a quiet sigh to a rushing storm. Two ice giants, yet two entirely different personalities, one quiet, one wild, one dreaming, one dancing in unseen winds. And as this chapter draws to a close, we arrive at the very edge of the sun's immediate influence. But the journey does not end here. Beyond Neptune's roaring blue storms lie smaller, colder, more ancient worlds. Places where winds are not storms of gas, but whispers of ice. Where comets drift with memories of the solar system's birth sealed inside their frozen hearts. From the deep blue sea of Neptune, the story now moves into the dark frontier, toward the icy realm where ancient travelers of the cosmos wait to be found. Leaving Neptune, with its supersonic winds swirling through a boundless blue, the journey seems to touch the final threshold of the great planets. But just when the listener might think there is nothing new beyond those storm-filled giants, space opens a different path. Not a return inward, and not a continuation toward more gas worlds, but a gentle descent to a smaller, quieter, strangely intimate place. From the grandeur of winds roaring at the edge of the solar system, the story softens into a world tucked deep within Saturn's domain. A moon that appears silent, but secretly holds a weather cycle of its own, complete, delicate, and poetic in a way that feels almost human. This is Titan, a place where rain is not water but methane, where the atmosphere is thicker than Mars's, and where darkness and light blend into a muted orange haze reminiscent of Earth's most ancient dawns. Titan emerges like a hidden realm inside the cold, outer void. From a distance, its surface is draped in a dense orange mist, scattering sunlight into a pale gold glow, soft, mysterious, and otherworldly. It is the only moon in the solar system with a thick atmosphere, so thick that its surface pressure is comparable to Earth's. That atmosphere, composed mostly of nitrogen, feels eerily familiar, yet mixed with methane and suspended hydrocarbons that tint the entire sky in a perpetual, subdued amber glow. Imagining a step onto Titan pulls the listener into a strangely emotional state, at once familiar and foreign. Underfoot, the ground is not rock in the usual sense, but frozen water ice, hard and brittle like glass. On that icy crust, fine grains of hydrocarbon snow drift down during the long, frigid nights. On the horizon, the sun appears only as a faint yellow smudge filtered through the thick haze. Yet Titan is not simply cold. It has weather, a full, intricate system with a rhythm all its own. In the dense atmosphere, methane clouds drift slowly, gathering into broad formations as Titan's seasons shift. When these clouds thicken, rain begins. Not water rain, but drops of liquid methane falling so slowly it feels as though time itself has loosened. Under Titan's pressure and low temperatures, each raindrop falls gently, like a bead of tiny translucent glass, landing on the frozen surface with a delicate shimmer. At 190 C, methane acts the way water does on Earth. It evaporates, condenses, forms clouds, and falls again as rain. Because of this, Titan has lakes, seas, and rivers, vast bodies of methane and ethane liquid. These lakes cluster mostly near the poles, including the enormous Kraken Mare, often described as a true sea. Their surfaces are eerily still, almost mirror-flat, as though time has paused over these silent shores of ice and hydrocarbon. In the dim morning light, methane fog gathers above the lakes, wrapping them in a ghostly veil. Everything appears softened, blurred, as if Titan is dreaming. Scientists have even said that standing on its shores would feel like glimpsing an early Earth, before life emerged, when the raw ingredients of chemistry were taking their first breaths. Occasionally, Titan experiences powerful methane storms. A small shift in temperature, just a few degrees, can draw thick clouds together and unleash a torrent of rain strong enough to fill dry river channels. These rivers do not run with water, but with liquid methane flowing along icy highlands, carving valleys and channels remarkably similar to those on Earth. Their shapes are evidence of long, steady erosion, proof that Titan's surface has been sculpted by rainfall for ages. After a storm, the orange haze returns, muting the sky once more. The sun becomes only a faint glow, and Titan sinks back into its quiet, living stillness. Not a dead stillness, something gentler. As if Titan prefers not to show itself all at once, but only in fleeting scenes. Titan is also the only place beyond Earth where humans have softly landed a probe on a surface with an active, weather-bearing atmosphere. In 2005, ESA's Huygens lander touched down and sent back the faint sounds of wind sweeping past. A startlingly tender reminder that even here, in this distant cold, wind still speaks. Titan is like a scientific fairy tale, a moon, yet with a denser atmosphere than Mars, a place where rain falls, rivers flow, and seas glimmer in twilight, but all made of methane instead of water. Its cold rains fall onto silent seas, creating a somber, romantic beauty, a poem written in hydrocarbons across the canvas of a frozen night. And as this chapter closes, the journey prepares to shift once again, from Titan's soft mysteries back toward the grander paths of the solar system. For after worlds with their own storms, seasons, and cycles, the story now turns toward ancient travelers, comets and icy wanderers carrying the memory of the solar system's dawn. From Titan's quiet orange dream, the journey moves onward, toward the deep, dark ice where old cosmic visitors wait to continue the tale of universal physics in a new and unexpected way. Leaving Titan, where methane rain falls in slow, delicate threads onto still hydrocarbon lakes, the journey closes the chapter of small, emotional worlds, places where weather follows familiar rules but uses unfamiliar materials. Titan is like a tiny amber lantern hanging beneath Saturn's rings, mysterious yet warm in its eternal orange glow. And from that scene, the story begins drifting away from moons with their own living cycles, stepping outward toward the edge of the world we call home. But this step is more than a change in distance. It is a shift in feeling, into solitude, into slowness so profound that time itself seems to stretch with the breaths of the world we're about to meet. From Titan, a moon with rain, lakes, and seasons, we move to a place where every motion is soft as a whisper, and that place is Pluto. Pluto enters the journey like a symbol of distance itself, a small world left behind at the outer border of sunlight, yet holding a beauty found nowhere else. Sunlight reaches Pluto only faintly, so faintly that to stand on its surface would feel like standing under perpetual twilight on Earth. And yet that very faintness turns its frozen plains into shimmering surfaces, glowing with pale blue-white light like fields of crystal. Pluto's surface is sculpted from nitrogen ice, methane ice, and carbon monoxide frost. At 230 degrees, everything becomes brittle as glass, yet capable of flowing like wax under the tiniest warmth from the faraway sun. Vast plains stretch across the landscape, especially the bright, heart-shaped region known as Tombaugh Regio. This heart is real, not imagined, formed by an enormous basin coated with gleaming nitrogen ice, shining softly against the tan and golden hues of the surrounding terrain. It feels like Pluto is offering a quiet greeting from the edge of the solar system. Pluto does have an atmosphere, though so thin it seems almost impossible. Surface pressure is only 100,000th of Earth's, but it is enough to create a faint halo of blue haze around the planet, most visible during sunset. In 2015, the New Horizons spacecraft captured that ethereal scene, a delicate blue outline encircling Pluto like a whisper of light. The color comes from hydrocarbons scattering the sunlight, an unexpectedly gentle contrast between the freezing world below and the last fragile rays from the distant sun. Pluto's breath moves through a cycle so long it defies ordinary intuition. Because of its elongated orbit, there are centuries during which Pluto drifts closer to the sun. In those rare times, nitrogen ice gently sublimates, turning directly into gas, and forms a thin atmosphere that wraps the world in a soft, hazy blanket. But as Pluto moves away again, temperatures plunge. The atmosphere condenses back into snow. Tiny crystals of nitrogen float downwards, drifting onto the frozen plains. Imagine a winter that lasts for centuries. Slow, silent, patient, nitrogen snow settles onto mountains made of water ice, harder than granite, tinting their peaks with fresh frost. Then, after hundreds of years, a spring returns. The faint sunlight warms the land just enough to lift the nitrogen back into gas, forming a new atmosphere. It is as though Pluto inhales and exhales across epochs, each breath longer than the lifetime of entire civilizations. What makes Pluto such a poetic stop in this journey is the delicacy of its weather. It is not violent like Jupiter's storms, nor surreal like Titan's methane rains, nor ferocious like Neptune's gales. Instead, Pluto's weather is slow, subtle, and deeply moving, like a long sigh from the universe, a shift so gentle you almost miss it unless you listen with your entire being. The blue haze around the planet feels like a memory suspended in space. The nitrogen plains reflect light with a soft glow, making Pluto seem like a small gemstone forgotten in a corner of the cosmic table. And Tombaugh Regio's heart-shaped gleam feels strangely human, as if nature left a quiet note in the most remote place imaginable. Even at the farthest edge, there is beauty that stirs something inside us. Pluto marks the threshold between worlds we can still imagine as places and the vast, untouched frontier beyond, a realm where icy bodies drift like ancient travelers. Beyond Pluto, sunlight weakens even further, temperatures collapse, and time stretches toward eternity. But in that darkness, another story waits. The story of comets, those icy wanderers carrying the oldest memories of the solar system. And so, when we leave Pluto in this chapter, the journey does not end, it unfolds. From Pluto's delicate breath, we move into the realm of ancient frozen travelers, where every orbit, every glimmering tail carries a message from billions of years ago. Those wanderers are waiting in the next chapter, in the quiet outskirts where comets drift through endless night, leaving Pluto behind. Pluto, where the faint breath of its fragile atmosphere fades into darkness like a ribbon of pale blue mist. The journey drifts farther and farther from the familiar boundaries of the solar system. Pluto closes the chapter of worlds that still cling to the sun's orbit, distant as they are. Still members of the planetary family gathered around our central star. But beyond the quiet path where Pluto glides in solitude, space unfolds into a new layer of mystery. Stepping past that dim region of light, the story seems to touch a wide-open doorway leading into a realm of deep wandering, a place where ancient travelers have no home, no anchor, only orbits stretched to infinity and loops that take millions, even billions, of years to complete. It is right at this intersection of belonging and drifting that the next characters in our story wait: the comets. Unlike Pluto, a dwarf planet with a surface, a landscape, and even seasonal whispers of atmosphere, comets belong to no stable region at all. They are scattered through places where sunlight is nothing more than a fading memory. Many comets dwell in the Kuiper Belt, just beyond Neptune's orbit, a region crowded with countless tiny, icy bodies circling the sun like a broken ring. But most, so many more, live far beyond that, in a structure almost impossible to picture. The Oort cloud, a hypothetical sphere spanning light years, filled with billions of fragments of ice, rock, and dust, all sleeping in the extreme cold, where the sun's gravity has weakened into a thread-thin pull. These comets drift for millions of years this way, unlit, unheated, leaving no trace. They are like fossilized memories from the solar system's earliest age, shaped from the primordial material that has never melted or changed. In the absolute silence of the frozen void, they exist like pages of a book no one has ever turned. But the universe never stands still. A slight tremor in gravity, a passing star brushing near the Oort cloud's edge, or the gentle tug from neighboring drifting bodies, can nudge a comet out of its slumbering orbit. When that happens, the icy world seems as if it has been awakened from a sleep that lasted across millennia. It begins its slow fall inward, toward the center, toward the place where sunlight remains warm and bright. At such vast distances, a comet is unremarkable. Just a black, frozen stone, so cold that every molecule lies motionless. But once it crosses the Kuiper Belt and drifts nearer to regions touched by the sun's energy, the smallest changes begin. A trace of warmth from the sun, so powerful to us, reaches the comet as nothing more than a breath. Yet even that is enough for the ices trapped inside its core to begin sublimating, releasing tiny jets of gas from hairline cracks. This is the comet's first turning point. Escaping molecules of ice carry with them fine grains of dust, forming a thin veil around the comet. This veil, as the comet gets closer to the sun, becomes the coma, the glowing halo that makes a comet look like a star wrapped in a luminous cloud. As the comet travels deeper into the inner solar system, sunlight and the solar wind begin to shape it more strongly. And this is when the wonder humanity has watched for thousands of years begins to appear: the comet's tail. Not just one, but sometimes two. A pale golden dust tail gently curved along its orbit, reflecting sunlight with the softness of silvered mist. And a blue, straight ion tail, stretched rigid by the solar wind and pointing directly away from the sun, extending for millions of miles. From a dark, silent chunk of ice, the comet becomes a streak of ethereal light across the sky. People who lived thousands of years ago saw these glowing spears sweep across the night and felt both fear and fascination. A long white sword hanging in the heavens, arriving without warning, fading without explanation. Unable to understand, they called it an omen, a divine signal, or a sign of upheaval. Today, we know comets are simply travelers returning along long, repeated paths. Not omens, not curses. They are ancient witnesses to the solar system's birth, carrying the most primitive materials: water, ice, carbon, dust, and possibly the first organic molecules. When a comet approaches Earth, not too close, only close enough for its luminous tail to grace our sky, humanity is given another chance to witness an ancient miracle. From afar, we see the comet as a bright point approaching, then slowly unfurling ribbons of soft light, like a flower blooming in the night of space. Every comet is a story. Some take decades to return, others need hundreds of thousands of years, and some sweep by only once, never to return again, their orbits carrying them forever out of the solar system. But no matter how long, they all share one essence: a journey from cold darkness into light, from absolute silence into fleeting brilliance, before returning to the place they came from. And with this, the door into the world of comets stands open. These icy wanderers are not just beautiful sights. They are the central characters of the next chapter, where the life of a single comet will be told from its formation, to its glowing moment near the sun, and finally to its quiet departure as if it had never existed. The journey continues, and in the next part, the story will follow that poetic path. The life of a comet, from the moment it is stirred awake in distant darkness to the moment it paints a soft streak of light across our skies, leaving behind the sweeping portrait of comets, those icy wanderers drifting through the endless dark. The story draws closer now, easing its focus onto the private world of a single celestial body. After understanding what comets are, where they come from, and why they suddenly blaze across the sky, this is the moment when the journey narrows, placing a gentle spotlight on one particular story, one particular fate. From the Oort cloud, a realm spanning light years where billions of ancient bodies sleep in absolute silence, we choose a character, a nameless comet in a vast ocean of ice, a tiny celestial traveler adrift in the immensity of space, a wanderer no one has ever called by name. And from this point on, its journey becomes the tale the listener is invited to follow, slowly, softly, like stepping into a long, drifting dream. Let's call this Comet A, a simple name, perfectly fitting for the anonymity shared by countless worlds out there. A has stayed in the Oort cloud for billions of years, in a place where sunlight is so faint it cannot even illuminate the thin frost on its surface. Around A, the cosmos is frozen at temperatures near absolute zero. Under such cold, time itself seems to stop. There is no wind, no rippling light, no collisions. Only endless darkness and the heavy silence of an ancient universe. A lies there, a blackened shard of ice carrying millions of years of untouched, unheated history in its frozen layers. And then, after a span that cannot be measured in days or years, something happens. Something astronomers like to call cosmic destiny. Perhaps another comet drifted close enough. Perhaps a distant star passed along the cloud's edge, leaving the faintest tremble in the gravitational field. Just one delicate disturbance, so small, so fragile, was enough to shift A's orbit. From a near absolute standstill, A begins to move, ever so slowly, ever so lightly. but enough to set it on a path toward the place where light is calling. A begins its journey at a speed so small it is almost imperceptible. But with each passing year, the sun's gravity pulls it faster. It is a voyage that may take millions of years, yet for A, everything unfolds in the rhythm of the cosmos. Never rushed, never sluggish, simply steady, inevitable. One day, A crosses the boundary where Neptune circles. Sunlight here is still weak, but thousands of times brighter than anything A has ever known. And something miraculous begins. A portion of its icy surface warms just enough to sublimate. Tiny jets of gas seep from hairline cracks, carrying fine dust particles with them, forming a delicate haze around the nucleus. This is the coma, the first sign that the comet is waking. As A travels deeper into the realm of the giant planets, the coma grows clearer. Beyond Uranus's orbit, A looks nothing like the dark lump it once was. It is now wrapped in a faint, luminous halo, like a wisp of vapor around a coal just beginning to glow. Its frozen body, motionless for billions of years, is now breathing vapor with every touch of light. Near Jupiter's orbit, A begins to bloom with brilliance. The coma swells into a vast glowing sphere, thousands, even tens of thousands, of kilometers wide. Sunlight streams through the gas molecules and dust grains, making A shine like a gentle ember drifting in the night. At the same time, the solar wind, those high-speed particles rushing outward from the sun, strikes the cloud around A, sweeping some of the dust and gas away to form its first pale tail. That tail stretches opposite the sun, a silvery ribbon millions of miles long, shimmering like a thin strand of light. And as A draws closer, that ribbon grows even brighter. By the time A approaches Earth's orbit, it reaches its peak brilliance. Its coma may span tens of thousands of kilometers, many times larger than its tiny nucleus only a few miles across. From Earth, on a quiet night, people might look up and see A as a soft torch suspended in the heavens. Its head glows with a gentle green tint from fluorescing cyanogen and carbon gases, while its dust tail gleams in white, curving like a kite drifting on a cosmic breeze. AA becomes a masterpiece of the universe, a world once buried in darkness now adorned in robes of light. But this beauty is only a fleeting pause in a long cycle. The comet races toward the sun. Smaller comets sometimes break apart at perihelion, the closest point to the sun, torn into countless pieces by heat and tidal forces. But our A is large enough, strong enough to endure. It sweeps past the sun as a bright, graceful arc, its tail flung outward along its bent path. An image so striking that many ancient civilizations once etched similar apparitions into their legends. And then, as in all natural cycles, after reaching its peak of brilliance, A begins to dim. The heat fades as it drifts away from the center. The coma contracts. The tail shortens. Frost returns across its surface, and A slips once again into the cold, leaving behind a faint trail of dust that Earth may one day pass through, giving birth to shimmering meteor showers. At last A returns to the far darkness. Perhaps centuries or millennia will pass before it comes back, or perhaps it never will, if its orbit carries it beyond the sun's reach. But its journey, from ancient shadow to radiant tail, has already become a single note in the cosmic symphony. And as we close A's story, the journey opens onward once more. For after the life of one comet, there remain countless tales of other visitors who have brushed past Earth, leaving their mark on human history and on the memory of the sky. The next chapter is where those stories unfold, softly, slowly, like a glowing timeline stretching across the centuries, leaving the life of A behind. A, the nameless comet that traveled from ancient darkness to a single radiant moment near the sun. The story feels as though it has completed a perfect circle. But as A's fading tail dissolves into the outer night, the listener may feel a gentle emptiness, as if, after following a silent wanderer, they suddenly wish to know more about others who have walked similar paths. A is not alone. Across the skies, humans have watched. There are comets that have not only illuminated the heavens, but have carved deep, enduring marks upon the human mind for centuries. From the intimate portrait of one small comet, the story widens again, like a doorway opening into humanity's archive of memory. The famous visitors who once passed by Earth and left behind chapters that time could not erase. Through the flow of history, it is no coincidence that a few comets became legends. Some were special guests with predictable cycles, striking beauty, or appearances that coincided with pivotal moments, so that people from ancient times to the modern age gazed up with awe and gratitude. And among all those names, Halley's Comet stands at the forefront. Halley is like an old friend who returns every 76 years, long enough that most people see it only once in their lifetime. Thousands of years ago, its presence was already being recorded. Ancient Chinese chronicles described it as a mysterious streak of light. The Babylonians etched its shape onto clay tablets. And then, in 1066, Halley appeared at the very moment England stood on the brink of the Battle of Hastings. On the famous Bayeux tapestry, it is embroidered like a torch blazing through the sky, an image both radiant and touched with the sacred weight of its era. In the centuries that followed, Halley continued to return, each time a silent witness to history. When Halley appeared in 1910, it shone so brightly it could be seen even in daylight. But society then still did not fully understand comets. Scientists detected cyanogen, a toxic molecule, in its tail. The news spread quickly, sparking waves of fear that Earth might pass through poisonous gases. An irrational worry, yet deeply human, reflecting the fragility of knowledge at the time. And then Halley drifted past, peacefully, leaving behind a gentle lesson. What we do not understand often frightens us more than the truth itself. By 1986, Halley returned again, now at a time when humanity finally had the technology to approach it. The European spacecraft Giotto flew close and captured the first detailed images of a comet's nucleus, a dark, 15-kilometer-long block of ancient charcoal-like rock. It was as though humanity looked into the true face of a visitor that had appeared in our skies for thousands of years. If Halley is the faithful visitor of history, then Hale-Bopp is the icon of the modern age. When Hale-Bopp arrived in 1997, it was so bright that for weeks on end, anyone who looked up could see its double tail stretching softly across the sky. Many people still recall that time as a memory filled with quiet wonder, a long white-blue stroke across the darkness, as if the sky were writing a letter to Earth. Hale-Bopp was not just an astronomical event. It became an emotion, a memory, a story carried by millions for the rest of their lives. Among the boldest visitors, one cannot forget Lovejoy, a sun-grazer comet, one of those that plunge dangerously close to the sun. In 2011, Lovejoy approached so near that many experts believed it would be completely destroyed. Yet the miraculous happened. Lovejoy survived its passage, emerging from the blinding light with a magnificent tail so striking that observers in the southern hemisphere described it as a silver ribbon drifting across the heavens. Lovejoy became a symbol of endurance, a beauty forged in danger. As we recount each story, it becomes clear that comets are not merely scientific objects. They have lived in humanity's imagination since the first humans learned to look upward. They have crossed ancient civilizations, slipped into poetry and faith, and inspired art as well as the dreams of children. Whenever a great comet appears, people everywhere pause to look up, sharing a moment suspended in silence and wonder. Comets do not speak, yet they tell stories. They whisper of the universe's history, of their own long journeys, and of the small but resilient nature of humankind, who have always dared to question the sky. These famous visitors are reminders that the connection between humans and the cosmos is not built solely on science, but on the deep, emotional tremor that arises when we witness a beauty beyond our control. This section is like a soft, lingering note after A's journey. After following an imagined comet from its slumber to its shining moment, the listener now gets to glimpse the real visitors that have shaped human memory. And as we close these pages of history, the story moves into its next layer. The truth that comets do not simply come and go, they sometimes bring gifts, icy fragments and primordial dust that fall to Earth like whispers from the dawn of the universe. The next section will tell the story of those gifts, of meteorites and cometary dust, as another language through which the cosmos speaks to our blue planet, leaving behind the nostalgic tales of famous comets, Halley, returning every 76 years like an old friend, Hale-Bopp, the blazing torch of the 1990s, or Lovejoy, which swept so close to the sun and somehow survived. Our journey drifts into a deeper layer of meaning. For when people of the past looked up at comets, they saw omens. Modern watchers see a fleeting beauty of glowing tails. But beneath all of that, comets hold a quieter, far more profound role. They are not merely visitors to be admired from afar. They are messengers that once touched Earth itself, carrying gifts so important they may have shaped life on our blue world. And so the story gently opens into its next chapter, one where listeners are invited to see comets not as distant wanderers, but as subtle contributors to the making of our home. From old tales of the sky, we step into the story of Earth itself, a place comets once visited in ways more powerful and fateful than anyone could have imagined. Imagine, the narration begins slowly, that in the dawn age of the solar system, the sky was nothing like the calm we know today. Back then, the planets were still forming, their orbits unsettled, and comets passed by far more often. Dirty, wandering icebergs from the Oort cloud or the Kuiper belt would plunge toward young planets like blazing stones falling from the heavens. Their impacts carved out deep scars and sometimes reshaped entire surfaces. But within that chaos, soft gifts were delivered. Some scientists believe that Earth's vast reservoirs of water, the oceans that cover more than 70% of the surface, may have been brought here largely by comets or similar icy bodies. Each time a comet struck early Earth, its ice melted, adding a little water to the growing picture. Not once, but millions, perhaps billions of impacts, over hundreds of millions of years, and not just water. In the dirty ice of comets, scientists have discovered organic molecules, the first building blocks of life. Amino acids, carbon-based compounds, simple ingredients that form the foundation of biology. When these molecules fell into Earth's ancient oceans, they could dissolve, mingle, change, rearrange, and begin the long chemical story that would eventually lead to living things. That image, comets as gentle fairy godmothers, bringing water and organic seeds to Earth, carries a soft sweetness. Not the violence of impacts, but the tender picture of melting drops of ice flowing into young oceans, merging quietly into the planet's deep history. Instead of only seeing fire and destruction, we see a silent offering, a gift from the cosmos meant to plant the first hints of a distant, unimaginable future. Still, the story does not hide Comet's other face. The universe always keeps its balance, the narration reminds softly. The bodies that brought water and organic compounds could also bring devastation. Earth's history has witnessed impacts so large, they reshaped entire ecosystems. Some theories even suggest that the extinction of the dinosaurs 65 million years ago may have been triggered by an object from space, possibly an asteroid, but perhaps a large comet. Yet the story here is not meant to stir fear, only to acknowledge that creation and destruction dance together in the rhythm of the cosmos. Today, the relationship between comets and Earth is far gentler. We no longer face frequent catastrophic impacts, but the echoes of comets still touch our planet every year, in a beautiful way. When Earth passes through trails of dust left behind on cometary orbits, tiny grains plunge into our atmosphere and burn into streaks of light. The brilliant Perseid nights of August come from the remnants of Comet Swift-Tuttle. The Leonids of November shimmer down from Comet Tempel-Tuttle. Each meteor lasts only a few seconds, yet it's enough for viewers to feel as though the universe is whispering a soft greeting toward Earth. The dust that comets leave behind turns into gifts of light, quiet, breathtaking moments on cool summer and autumn nights. And then, the story recalls a remarkable event, a moment when humanity witnessed a comet impact with unmistakable clarity. The collision of Shoemaker-Levy 9 with Jupiter in 1994. As the comet approached the giant world, it broke into many fragments, each one diving into Jupiter's atmosphere. From Earth, astronomers watched bright bursts appear, like silent explosions in the dark. Huge black scars formed in Jupiter's swirling clouds and lingered for months. Seeing that spectacle, many couldn't help but imagine Jupiter as a gentle giant, stepping forward to absorb frightening blows from comets, shielding the smaller planets inside, including Earth. And as time passed, those dark scars slowly faded under the force of Jovian winds, as though the planet were quietly healing itself. As this chapter draws to a close, listeners are left with a soft reflection. Comets hold two faces. They can plant the seeds of life, or they can bring an ending. Yet whether they create or destroy, both sides belong to the universe's grand design, a design in which every encounter, gentle or fierce, helps shape the futures of worlds. And from those encounters, the story is ready to open a new door, not about collisions anymore, but about the secrets comets carry within them. The ancient chemical records that help us understand the very origins of the solar system. The next chapter will guide listeners into the inner world of those icy grains, fragments of deep time still holding the first breath of the cosmos. In the previous chapter, where comets appeared as two-sided messengers of the cosmos, capable of sowing the seeds of life yet also bringing destruction, the journey seemed to touch a quieter, deeper layer of reflection within the listener. After witnessing how comets embraced Earth with soft grains of dust like gifts, and after watching the fierce collision of Shoemaker-Levy 9 as it plunged into Jupiter, the story can now widen into a larger perspective. That all of these things, those gifts, those moments of devastation, the storms, the cycles, are threads flowing into one vast current called cosmic destiny. Once we see comets both nurturing life and reminding us of the world's fragility, a natural question begins to bloom. Not only comets, but the planets, the storms, the entire solar system. Where will it all go? The wonders we see today, the grandeur of the Great Red Spot, the mystery of Saturn's Hexagon, the calm, deep blues of Neptune's oceans. Will they last forever? Or do they too have lifetimes of their own, shifting quietly according to unchanging laws the universe has set? And so the next part opens like a doorway into the far future of the worlds we visited. No longer bound to the present or the past, the story drifts toward moments yet to come. Moments hundreds of millions, even billions of years away. There, listeners are invited to look upon an endless river of time, where everything, from tiny dust storms on Mars to the great swirling tempests on Jupiter, has a final chapter and its own story of fading away. Imagine, the narration begins, that even the things we think of as eternal in the solar system change with the slow rhythm of millennia. Jupiter's Great Red Spot, a colossal storm that has raged for more than 3 centuries, has shrunk significantly in recent decades. Once wide enough to swallow 3 Earths, it is now only a little larger than Earth itself. No one knows when it will disappear entirely, but someday that storm will fade, like a final fierce breath dissolving into the giant planet's tapestry of clouds. The hexagonal storm at Saturn's pole follows the same fate. That astonishing 6-sided vortex, its edges sharp, almost impossible to believe, is something we have seen remain stable for decades, but nothing guarantees its permanence. A slight shift in wind speeds, temperatures, or atmospheric currents could distort it or erase it altogether. Neptune, with winds raging at 2,000 kilometers per hour, will not maintain that wild energy forever. As the planet slowly loses its internal heat over time, its winds will weaken, its dark storms will become rarer, and that deep blue world may grow quieter over the course of billions of years. Storms, no matter how large, are like living beings. They are fed by heat, by energy, by atmospheric contrasts. When that energy diminishes, their lifespans draw to a close. The future of the planets, then, becomes a gentle, melancholy symphony, where every magnificent vortex eventually softens into faint wisps of cloud. But the future does not end with storms. The biggest picture lies with the Sun itself, the center of every orbit, the source of light for every world. In about 5 to 6 billion years, the Sun will enter the final stage of its life, swelling into a red giant. When that time comes, the landscape of the entire solar system will change beyond recognition. Mercury and Venus will almost certainly be consumed by the expanding Sun. Earth lies in a fragile boundary. It may be engulfed completely, or if it barely escapes the Sun's outer layers, it will still be scorched until its surface becomes a desert of molten glass. Its atmosphere stripped away, its oceans evaporated. Any remaining life, if any still exists by then, will have long since departed. Farther out, the view is no gentler. The swollen Sun will flood the skies of Jupiter and Saturn with a deep crimson glow. These planets will sit beneath the light of an enormous star dominating their horizon. The intense radiation and heat may melt Saturn's icy rings, unravel stable atmospheric layers, and even vaporize portions of the gas giant's upper atmospheres. Their storms might surge for a brief moment, like one final breath from worlds that were once powerful, before weakening as the environment becomes too hot and too thin to sustain their swirling motions. When the Sun finally sheds its outer layers and contracts into a small white dwarf, its light will dim to a faint glow. Any planets that survive will circle in cold darkness. No more storms, no more methane rain, no more vast spirals, only an almost absolute stillness. Yet the narration remains gentle, because this is not a sorrowful prophecy, only a description of the universe's natural cycles, cycles that every star and every planet must pass through. Just as comets carry both life and endings, planets too have beginnings, peaks, and twilight eras. There is nothing to fear. This is simply how the cosmos has moved since the beginning of time. And at the end of this section, listeners are guided to a softer, brighter thought. In every fading, there are signs of new creation. When the sun becomes a white dwarf, the material it casts off will mingle with interstellar gas and dust, perhaps one day forming the seeds of new stars and new planets. The cycle does not end, it continues. And this leads smoothly into the next chapter, where the story expands beyond the solar system itself, into the wider universe, to explore what remains long after the planets have finished telling their stories. We've just traveled through the future of the planets and their storms, a tapestry stretched wide across the vast canvas of time. And the story still carries the echo of stillness. The listener now stands before an immense horizon, the great red spot fading away, Saturn's hexagon dissolving, planets slowly consumed by the red glow of an aging sun, and in the end, only a faint white dwarf turning quietly in the silent dark. Yet within that moment, a moment that seems like an ending, there is a thin thread of hope quietly reaching forward. For the universe does not understand stopping. When one chapter closes, the next has already begun long before. And so the story continues, gently flowing into its 17th part, where we look at the fate of comets and the endless cycle of matter. A reminder that the cosmos is always renewing itself. Imagine, the narration begins with a calm simplicity, that the comets we've followed across this long, sweeping journey through the universe will one day grow old as well. Each comet, every time it returns to the inner solar system, leaves behind a thin trace of dust and ice, like the softest footprints before it drifts away again. But after hundreds of orbits, their ice slowly runs out. Water vapor and gases grow faint, and eventually, they remain only as small, bare stones, silent and unremarkable, hardly different from dim asteroids. Some comets meet their end sooner, plunging straight into the sun during an overly close pass, or striking a planet and turning to dust. Others, nudged by sudden gravitational tugs, are thrown out of the solar system entirely, wandering into interstellar space as lonely travelers drifting forever through the dark. Though the image feels somber, the narration keeps its gentle rhythm, for that is only half the truth. The other half is renewal. As old comets fade, the universe nurtures the possibility of new ones. One day, after the sun has passed through its red giant phase and contracted into a white dwarf, it will blow off its outer layers into space. Those layers may spread far enough to reach the edges of the Oort cloud, a region where billions of icy bodies still sleep. That wave of material may stir those distant icebergs, sending some outward into interstellar space and pushing others back toward the center. Even though the solar system will no longer be the place it once was, these motions continue naturally, like the final breath of a dying star setting a new heartbeat in motion. And beyond that, new comets are not only born from the remnants of our old sun. Across the galaxy, billions of other star systems exist, each with its own rings of ice, its own Oort clouds. Now and then, a foreign comet wanders into the space near our sun, just like Oumuamua in 2017 or Borisov in 2019, captured briefly by the gaze of telescopes. These visitors are living proof that the universe is not made of isolated islands. It is a web in constant motion, where paths cross, and journeys intertwine, the narration widens into an even broader image. Imagine a few billion years after the sun has faded, another star passing near the space where our solar system once lived. Its gravity might sweep up fragments of asteroids, the dried cores of comets, and lingering dust, pulling them into a new stream of material. Those fragments may drift into a cold molecular cloud, one of the nurseries where young stars form. When a new star ignites within that cloud, the old material will fold into the structure of its newborn system. This is the bright center of the idea of cosmic destiny. Nothing truly disappears. The matter in comets, in planets, even in our own sun, will contribute to the next cycle of creation. Some molecules of water may endure for billions of years. Some organic compounds may survive through generations of stars. And somewhere in a distant corner of the galaxy, far into the future, those molecules may become the first drop of water on a new planet, or the building block of a new kind of life. The listener is gently reminded that they too are part of this cycle. The water in their body may carry the signature of ancient comets. The carbon in their cells was forged in the core of a long-dead star. All of us, every individual, every creature, every breath, are built from the material of stars and comets that perished ages ago. Which means the future of the universe does not belong only to distant worlds. It also touches us, the quiet listeners in the night. As this part comes to a close, the narration paints a soft, poetic image. The universe as an endless ocean. The planets, the comets, the stars are merely waves, sometimes rising in great swells, sometimes dissolving back into the water. But the ocean itself remains. Deep, serene, eternal. One wave fades so another can form. The solar system will one day slip into the memory of the cosmos, but its material, everything that once made its light, its life, its storms, will continue its journey onward. And so this section ends with the gentle resonance of renewal. Cosmic destiny is not a final period. It is the eternal cycle of new beginnings, where everything is given a chance to become part of another story. Farther away, but just as beautiful. Leaving the previous part behind, where the cosmic cycle of matter unfolded like a quiet reminder that nothing truly ends. The story drifts into a gentler rhythm. After the listener has traveled through visions of comets slowly dissolving over time, planets changing with the sun's aging, and the material of once radiant worlds eventually fading into molecular clouds to begin a new cycle, a settling calm begins to form. As if after witnessing the universe move through birth, disappearance, and rebirth, the listener's mind naturally slows, softens, and returns to a feeling that is deeply human, the simple desire to rest in peace and quiet. And from that quietness, the final chapter opens softly, like a warm breath from the universe offered to someone about to drift into sleep. Let's return for a moment, the voice murmurs, to the place where every journey begins, Earth. A wide night sky appears, familiar, yet carrying a hint of something boundless and hard to name. After passing the giant Jupiter, Saturn's Hexagon, Neptune's supersonic winds, and the wandering comets of distant space, Earth suddenly feels tender again. The echoes of the cosmos begin to close, and the listener is invited back into the feeling of lying beneath a clear, dark sky, where the breeze slips gently through the trees and the quiet seems to lean in, listening to the story just told. The scene completes itself like a perfect circle. We began under Earth's night sky, then traveled through the gas giants, crossed red, dusty deserts, watched methane rain fall on Titan, followed the shaping of a comet's glowing tail, observed ancient impacts, and looked into the far future of the solar system. Now, every image returns, not overwhelming anymore. They appear lightly, like glowing ashes of memory, shimmering and drifting away, as if lulling the listener into the soothing calm of understanding. Somewhere on Jupiter, the voice continues softly. The enormous red storm still turns slowly, as if keeping time for the planet's eternal layers of gas. Even though we know that one day the storm will fade, for now it remains. A quiet testament to the endurance of extraordinary natural phenomena. And on Saturn, the hexagon at the North Pole continues its steady rotation, like a mysterious geometric painting no earthly artist has ever created. Farther still, beyond the boundaries of the great planets, a lone comet may be gliding through deep darkness, unknowingly sweeping its shimmering icy tail like a silver brushstroke across the night. Fragile and small as it is, it carries the story of ancient material that once touched Earth, helping to create the oceans and eventually life. Amid these drifting images, the universal laws of physics, universal physics, reveal themselves as the invisible thread connecting everything. Whether it's a soft breeze on Earth or a colossal atmospheric swirl on Jupiter, a dust grain in a comet's tail or a water molecule inside the human body, each follows the same principles. That shared order is what creates harmony. The universe is not scattered chaos, but a structured symphony where every motion obeys a common rhythm. In the same way, the voice continues gently. The icy comets from the edge of the system brought us the water we drink today, and some of their organic molecules now exist in every cell of our bodies. That truth forms a profound connection. We do not only look at the universe from the outside, we carry a part of it within us. Its presence is never loud. It is a quiet awareness that we and the lights in the night sky have never been separate. The narration slows, blending into the breath of the night. The universe has its storms, its moments of turbulence, but everything eventually returns to stillness. Just as humans have busy hours and worried days, yet always find a place to rest. No matter the roaring winds, the violent collisions, the planetary upheavals, or the deaths of stars, all events unfold beneath a greater shelter, the fundamental peace of space. And as the story reaches its end, the goodnight wish arrives not as a simple phrase, but like a thin, warm breeze carrying the comfort of the night sky. The listener is invited to release every lingering thought, letting the knowledge soften and settle like gentle light drifting into the mind. Let the universe lull you to sleep, the voice whispers, just as the stars have lulled Earth for billions of years. In the quiet darkness, the star-filled sky seems to lean down, embracing the listener with an expanse that is vast yet tender. Somewhere out there, cosmic storms still turn, comets still glide in silence, and time continues its steady flow. But for the one falling asleep, these motions no longer stir the mind. They become a deep and peaceful hum, a wordless lullaby woven from universal physics. Sleep well, wrapped gently in the universe,